For Project 3, I aim to complete the baseball program as well as correct the undesired behavior seen in Project 2. Specifically, I sought to use color detection for base verification, implement consecutive base traversal, and correct the motion drift experienced during takeoffs and landings. Thanks to the CoDrone tutorials, the color sensing was simple. I trained a dataset based on my desired colors. The bases are colored green for the home base, red for first, yellow for second, and blue for third. One characteristic of the drone's color sensing is that the drone must be grounded and motionless for about 1 to 2 seconds in order for it to activate. This means the drone must land on each base in order to verify it is the correct one, a fact that affected how I handled waypoints later in the project. For navigating multiple bases, rather than one large function that had a lot of condition cases, I broke the movement function into two. The first function, move, simply moves the drone from its current base to the next base in the arrangement. The second function, move bases, calculates how many times move must be called based on the input value. So for example, if the drone is on the second base and a triple is input as the next value, move bases will only call move twice in order to get to the home base. Handling the function in this way made development easier to debug since the logic remains the same for each movement. The only difference is the movement direction. Finally, I moved to correct the drifting problems seen in Project 2. As a review, the drone will experience drift upon takeoff, leading to inconsistent flight trajectories and landings. To correct this, I used the drone's ability to set and navigate waypoints. In the process of doing so, I discovered that waypoint navigation is not completely based on relative position. Waypoints are set using relative position as expected. However, from reading the source code, the drone tracks its position in absolute coordinates by saving its position upon landing. When the drone is commanded to then seek a saved waypoint, the necessary displacement to reach the point is calculated using this previous landing value, meaning the drone seeks waypoints in terms of absolute position. The takeaway from this is that because waypoints are set relatively and sought in absolute coordinates, all waypoints must be defined before the drone's first landing. This presented a problem, however, because, as mentioned in the color detection section, the drone must land for each detection. To solve this, I created a new landing method that resets the stored X and Y landing coordinates to 0, 0 upon each landing. As a result, waypoint traversal is now fully relative. Each takeoff point is now treated as the drone's origin. This also allowed me to correct the takeoff drift by commanding the drone to fly to 0, 0, otherwise known as its takeoff point, after becoming airborne. I was able to achieve all of the goals set for this project. However, merging all of the working subsystems together yielded unexpected results. Though the program's logic is sound, occasionally the drone performs behaviors such as landing prematurely, halting completely after landing, spinning the propellers without achieving lift, and in one particularly surprising case, taking off rapidly and hitting the ceiling. I'm not sure what causes this behavior. I reviewed the code multiple times and didn't find any bugs. There's likely some aspect of the drone's operation that I haven't taken into consideration, but it's also possible that the drone itself may have an unknown issue. Testing the code with another CoDrone could reveal if the problem is indeed my code or the CoDrone I'm using. In any case, though the project was not a complete success, I did learn a lot about both the CoDrone and aerial robotics in general. Thank you for watching.